Hi, welcome to my tutorial on being able to find the gradient of a straight line graph from its equation. Now what we can see here on the left, I've got the graph of y equals 3x minus 2. And if we have a look at the gradient of this graph by drawing a triangle between 2 points, so I'm going to form a triangle between, I'm going to go from here, and I've made myself a right angled triangle, and I know the gradient of that line through dividing the height of the triangle by the base of the triangle. Now if I do that, I get my gradient as, well, let's look at the difference here. It's basically the difference in the y coordinates. Well, this one here is 1 and the one at the top here is 10, so the difference there is 9. I divide that by the difference in my x coordinates, or the base of the triangle, which is 3. So 9 divided by 3 gives me my gradient of 3. Now if we have a look at this, if we look at the equation of the graph, you can see y equals 3x minus 2. And we can see that this number here, 3, is the same as the gradient. Now, is that a coincidence, or will that always be the case? Well, what we're going to do is I'm going to look at another equation here. It's an equation of a straight line graph. I'm going to rearrange the equation, then plot the coordinates, then plot the graph, and see if we've still got the same gradient here as the number next to the x. So let's have a look at this one then. Now it's not in the correct format. We want it in the form y equals something x plus something. We call it y equals mx plus c. So we need to rearrange this equation a little bit. So what I'm going to do is I'm going to start off, I'm going to take this negative 9x over to the other side, where it's going to become a positive 9x. So I'm going to have 3y equals positive 9x plus 12. Still not in the correct format. We need it to be y equals something x plus 12. So what we need to do here is we need to divide this side by the 3. We're actually dividing both sides by 3, but if I divide 3y by 3, I get 1. So I'm left with y equals 9x divided by 3 is 3x, and 12 divided by 3 is 4. So I've got my equation now in the form that I want it, y equals mx plus c. Now what I'm going to do is I'm going to plot the coordinates here. I'm going to find my y coordinates and then plot them. So I'm going to put my x coordinates into the equation to work out what y is. Let's start off with the positive. So y equals 3 times 3 is 9 plus 4 gives me 13. I'll now put 2 in place of x. 3 times 2 is 6, plus 4 is 10. 3 times 1 is 3, plus 4 is 7. 3 times 0 is 0, plus 4 is 4. 3 times negative 1 is negative 3, plus 4 is 1. Should be able to see that this now is going down in 3s. So I could continue that on. 3 times negative 2 is negative 6, plus 4. I'm going to get negative 2. And then if I go down 3 again, I'm going to get negative 5. I'm now going to plot these coordinates here on my grid here. So negative 3, when x is negative 3, y is negative 5. When x is negative 2, y is negative 2 as well. When x is negative 1, y is 1. When x is 0, y is 4. When x is 1, y is 7, and when x is 2, y is 10. I can't fit that on my graph, but what I'm going to do now is I'm going to join these up, and that's going to give me my graph of y equals 3x plus 4. Let's have a look now and see what the gradient of this one is. Is it going to be 3x? Let's have a look. And take a point here, and I'm going to take another point. I'm going to take this one right down here this time. I'm going to form myself a right angled triangle from this There's my right angle. Should be able to see the triangle there. We want to find the difference in the y coordinates. Well, this one's 7 and this one here is -5. So we've got a difference here of 12, height of my triangle 12. The base of my triangle is 4. So if to find my gradient, I do m equals 12 divided by 4, I'm going to get my gradient of 3, which relates to the 3 in front of the x. So what we can say about this, as long as we've got our equation for our graph as y equals something x plus something, the number that's next to the x is what tells us what the gradient of the graph is.